Oh, hi Michael.
Hello.
How's it going?
Good. How you doing?
Good. Thank you. A couple of minutes to see if everybody else joins.
Hmm.
And then we start. In Discord as well.
Good morning, Santiago.
Hi Matt. How are you? How was the DeepSeek updates?
It was really good. It was really good. We went for about 2.5 hours. Um, Discord is interesting because when you have more than 25 people, we had about 70, I think. It goes to audio only, no video. Uh,
Mm-hmm.
but it was good. It was really good.
Nice. Okay. Mhm. Okay. Let me start with some announcements on agenda. So today we're continuing talking about DPO. Michael is presenting that. And after that, if I'm not wrong, Eddie is gonna introduce us to RAG, some RAG stuff that he has done. Oh yeah, and then some reminders. We're gonna have a Ask Me Anything session with Sebastian, the author of the book that we're reading, on February 11 at 3 p.m. UTC. That's a Tuesday. So yeah, come prepared with questions. I shared I shared a form. So if you cannot come to the session, you can submit the question by the form through the form, and we can ask it for you. Then, what are we reading next? Looks like AI engineering um, one. Well, there's still like 800 and something minutes left. I just took this screenshot. So things might change, but I don't think they're gonna change. Um, so yeah, 15 votes for engineering from Chip Fusion. I was thinking maybe the team expected first meeting about this book on February 23rd. I don't know if that's too soon or too late. We can discuss it. That's 1, 2, 3. Yeah, in 20 days. Uh, that should gives us time to buy the book or get the book. And yeah, yeah, and read the first chapters, read the first second chapter. I don't know. We need to actually like formally announce it and see how we're gonna split the sessions and stuff. Isn't that a little late? Says someone. Maybe it's a little late. I don't know if you would like to do it before. We have the Sebastian's call on 11, so we might start on the 16th. Um, I don't know if the 9th is too soon for anybody to get the book and read the first chapters. But yeah, what do you think? anybody has strong opinions about it.
Sorry, trouble unmuting. If I may, the first chapter of most books usually are available uh,
Mhm.
on for free online. So if anybody wants to get a head start even before getting their hands on the book and getting it delivered, shipped, and so on.
Mhm.
So I think, meeting earlier on the 16th, time is always of the essence,
Yeah,
would be my vote. And I think somebody also messaged the same thing.
yeah. Also, well, yeah, sounds good. Also, depending on where you buy it, I guess you can get the ebook while the printed version arrives. Like if you buy it directly from O'Reilly, you get access to ebook sometimes. I don't know if that's for every book. But for example, with LLM, building an LLM from scratch, uh, I bought it. I bought the physical version, but they also had the online version, like the uh, for free if you buy it printed. So I had access to the online version before the physical one arrived. So that might be also an option. So expected of the 16. Good, good. All right, I'll share more details about that uh, today or during the week. That's everything I had to say. Back to you, Mike.
Thank you. Let me share my screen. Okay. Is everybody seeing this?
Yes.
Okay, I'll make it a little bit bigger. Let me know if the size is all right. Okay.
Sounds good.
So just to remind us all where we were last week, I was telling you about this preference trading technique called DPO, and we started out with compiling a data set of these preferences. So we had these rejected and chosen responses to a prompt, and I was talking about the loss formula, and we were going through it kind of step by step. I think that's where we finished up, but I'll remind us quickly just about the components of this function. So we have our X, which is our prompt, and then we have YW and YL, so our winning and preferred, or our preferred and losing response. And then we're drawing from that distribution this triplet of X, YW, and YL, and we are finding the expected value or the average from that distribution. And then we calculate uh, this formula here, which has these log ratios. So each one of these is a probability of either the winning response or the losing response on both your policy model and your reference model. And if you recall, our reference model is our originally trained SFT model that we're keeping fixed. And what we want to is to make sure that this one is numbers high, so that there's a big chance that our our policy model prefers the winning response over the losing response. And then there's this beta hyperparameter, which we can change to penalize more strongly. So if it's larger, we'll penalize the model more strongly from straying from the reference model. But we can keep it smaller if we want to be more conservative. Um, so yeah, just wanted to stop there and ask if anyone still had any questions about the formula. I'll go into the code in a second as well. Okay, so that's it's a scary looking formula, but when we start looking at the code, it's actually reasonably simple to understand, and it's slightly different. So we start with this compute DPO loss function, and what this assumes is that we've already computed those probabilities. So we already have our YW given X for our our policy model and our reference model. So we'll go through the code where we get that in a second. So, but in this function, we assume it's already been computed for us. So we pass those in, and then we also pass in the beta value, and it defaults to 0.1. And then you'll see the code itself is actually, it's just a few lines, and it's pretty easy to map that back to parts of our formula up above. The one thing to note is that, and it I had a note here, but we rely on this fact from math that you might recall that if you have log A over B, you can also express that as log A minus log B. So um, these these ratios here we actually express as a subtraction. So this is why you see we are subtracting over here. So that's what we're doing over here, and over there is just calculating those ratios. And then we do this subtraction of the inner terms. So that maps back to this subtraction. Um, and we actually multiply with beta here, but it's mathematically equivalent to what we see in the formula. And then we use this log sigmoid function, which is a PyTorch function that does the log and the sigmoid together. We flip the sign like we talked about. And then at the end, we calculate the mean. One other thing that we do, which is optional, but something that you'll typically do when you do this kind of preference training is to look at our rewards. And what these are is the margin or the difference between the log probabilities for our chosen and a reference model. And we will keep track of these as well, and we calculate the, the mean of these. And we'll look at that as we keep training, and I'll show you that in a second. So stop me if there's any questions about that. So now that we have this function, we can actually go and compute those log probabilities. So the way that we do that, I'm not going to go through this code deeply. I suggest that if you want to go through it afterwards, it's good to go through in a notebook. But one thing that is different here is that if you remember what we did before when we calculated cross entropy loss, we're doing basically the same thing. But because we have this custom masking code, so we are masking out parts of our prompt that contains the prompt template that we don't want to have any influence over our loss. That kind of forces us to re-implement cross entropy ourselves. And I had to go and remind myself again of what cross entropy loss is doing. And this is from earlier in the book. But basically, we are making use of this torch.gather function. And in the notebook, the author actually shows you a little bit of how it works. But we are basically going through the same steps and calculating cross entropy loss. But it's just because we have our own custom logic that we are doing it ourselves. But it's still just everything else works the same way. So then we can go ahead and use this new function and compute the DPO loss on a batch level. So we have this we can pass in a batch of our rows that we want to calculate this on, and we have to have our instantiated policy model and reference model, and we pass beta through. We can call compute log prob, so the function that I just showed you, um, and it will compute it for our chosen model. So, oh, sorry, the chosen responses. And then we can just still do the same thing for our rejected responses. So this is both on our policy model. And then we do the same thing for our reference model. So we compute the log probabilities for chosen and rejected on the reference model. We can get all of this together with our rewards. And we use that compute DPO loss that I showed you initially. We pass in those already computed ratios and the beta as well. And then what we get back at the end is just an overall loss and chosen rewards and rejected rewards. And then here's an example of just how we can use that on a batch of data. And for this batch, the loss that we get is 0.69. And then like we did before, we can create a method to calculate it on a data loader level. So very similar to what we had before. The only thing that's different is we're using this compute DPO loss batch to calculate it, but everything else is the same. We're just uh, calculating it on every single batch in the loader, and then we're accumulating the total loss, the total rewards, and total rejected rewards. And then at the end, we uh, calculate the average over here. And then the reason we can specify num batches is that, during training, you typically don't want to calculate this on all the batches in your loader. You're going to specify how many batches so that it's faster. It's for efficiency reasons. And then the last thing we need to do is create this evaluate DPO loss loader, which is just a convenience function for our training loop. And this calls this compute DPO loss loader on our both our train loader and our validation loader, and then return this dictionary that gives us everything together. So I went through that pretty quickly, but just the summary. So the flow is that we compute the logits using this compute log probs function that had that custom cross entropy loss implementation. Then we can compute the DPO loss using that function that implements the loss function that I showed you. We can then compute it on a batch level. That can then be used to compute it on a data loader level, and then evaluate DPO loss loader makes use of that. So that's all we need. So now we can train a model. So a lot of this is also should be very similar to what we did with SFT fine tuning. But there are some slight differences. We are keeping track of not just our losses, but we also keep track of these rewards. And then, yeah, we loop through the number of epochs. We get a batch in our train loader data, a batch of data from it. We do the usual deep learning training loop. So we uh, set our optimizer and we reset our optimizer. We compute the loss. We take a step backwards. We update our gradients, and then we keep training. And then um, every eval frequency, however much is set, we will call evaluate DPO loss and print out our losses and our reward ratios. So we can see it being printed out here. And then same as we did before, we'll also print out these sample completions from our model just to see what it's doing as we're training. So just before we start training, we will look at our initial losses. So we can call evaluate DPO loss loader on our models that haven't been trained yet. And we'll see that our starting loss is around 0.69. And then we'll also just look at an example or a couple of examples of what our model is doing right now. And if we give it instruction, because it's been SST trained, it'll act like in the same way that we did when we finished our instruction tuning. It's still be able to complete these responses for us. But what we're trying to do, remember, is to nudge it to be more polite. So what we're hoping to see is that if we've given these instructions, the model responses would not just be the correct responses, but they'll also be more aligned with our preference of being more polite. Okay, so we're ready to start training. We're going to use the Atom W optimizer here. There's a couple of is noted in a notebook that I worked through when you're doing DPO training that you want to think about when you're setting up training. So learning rate for DPO is typically set a little bit lower than you would for other kinds of fine tuning. And you also want to be careful about the number of epochs that you train for, because there's this phenomenon called model collapse that can happen if you train for too many epochs. I will talk about that in a second, and I'll actually show you an example of something I tried where I was able to induce this model collapse. But just be aware of that. And then again, importantly is this beta parameter that we've talked about a little bit. Typically, you'll set it the value between 0.1 and 0.5. Here we're using 0.1, which is sort of more of an aggressive value because what we're saying is we're allowing our policy model to change more from our reference model. So there's more of a pronounced effect of this DPO training. And then for these examples that we'll print out, we just grab a row from our validation data as our start context. And then we can start training. So I ran this on my computer, my laptop, and it trained, I think, for around 5 minutes. I don't see timing here, but it was about 5 minutes on my MPS device, so on the Apple Silicon. And you can see our losses going down, and our rewards are sorry, our margins are going up, which is both good signs for DPO training. But like we did before, we can actually plot out our loss curves. So we can see that our training loss goes down and validation loss goes down, both good signs. And we can also look at the margins. This label here is wrong. I have a bug in my code, but this should actually say our rewards, not loss. But both of these numbers go up, which is good. And then we can actually look at what our model is doing. Like I've emphasized previously, is I think it's always good to not just look at the metrics, but look at some outputs of your model. here are some instructions that we're giving it. Here's the correct response, and this is what our reference model says and the policy model. Um, Honestly, when I was doing this, I didn't see a big difference. I wouldn't say that my responses were necessarily more polite. They were slightly different. Um, Maybe this one could be interpreted as slightly more polite. So the correct response is dance can be classified as a verb. The reference model said exactly that. The policy model said the input string dance could be classified as a verb. Maybe it's slightly more wordy. Maybe that's more polite. In the notebook, Sebastian had this example that where it said dance could be classified as a verb, which he said could be interpreted as more polite. But because I was training on slightly different data, I didn't have the same outputs. But yeah, that's basically it. So um, that's end-to-end DPO training. Uh, a couple of things that you could still try or follow-up ideas that I might also play with is playing with the beta values, so experimenting with different values of beta and seeing how that affects the model and its training. Another thing you could do is actually print out a lot of responses from your model and put them into a table or a spreadsheet and look at do like a side-by-side comparison. Um, One thing that's interesting is that you could use another classifier to help quantify how your model's doing. Uh, some examples could be either a classic machine learning model that's trained specifically as a politeness classifier, or maybe an AI judge. So that's where you have like a stronger LLM that you're showing these responses to. The same way as we generate our data set, we can also use another LLM to evaluate our model. Um, we could play with the data set. We can see if we can make it better. Or we can try different strategies for masking. So changing that custom collation function so that we could maybe try not masking the prompt token, seeing how that influences things as well. There's one thing that I wanted to look into, which is this model collapse that I talked about earlier. And I actually did that in another notebook. So I'll just open that. Actually, it was here. Um, and this notebook I copied and pasted basically from it was everything is the same as the previous notebook, but I just changed one thing. I cleaned it up a little bit, but I basically just made one change, and it's the number of epochs that we trained for. So if you recall, previously we had one, and I changed this to five, and then left it running. It took a little bit longer to train. Um, But what was interesting to notice here is that our loss keeps going down. Both our training loss and our validation loss. At some point, it seems to sort of stabilize. Um, but we can see that our margins keeps going up. So that looks good. But if you look at the output as we're training, at some point, if I can find it, you see it kind of starts outputting gibberish. So it starts just repeating the same word over and over. So it just keeps saying would, would, would. And what I believe is happening here is that it's kind of like overfitting where the policy model is learning that certain tokens uh, give you lots of reward, makes the loss really low. So it starts over optimizing and just repeating itself. So that's something that you have to be kind of careful of when you're doing DPO training. And either you would, I think here you would, stop training at that number of epochs and then rather look at other hyperparameters like beta or your data or your whole training setup to see if you can avoid that kind of problem.
Pretty interesting. Looks like then wood is a very polite word. And then and the reward model just knows it.
Mhm.
Great. That was a great DPO overview. Thanks, Michael. I don't know if you have something else.
No, maybe just I can quickly mention I don't even have a link or anything, but there are other sort of related techniques in this field. There are ways that people have done incremental DPO, which I just briefly read about,
Mhm.
where you kind of do this process of generating data and then doing DPO training and then using that model to generate more data, which is really interesting. So you're kind of self-improving your data set as you go. And then there's also a technique called KTO, which I've yet to kind of dig into yet, but from my brief like understanding is that what that allows you to do is to train on, you also have preference data, but it doesn't have to be these preference pairs that are related to each other. You could just give two examples of a good output and a bad output. And they don't have to be for the same prompt. Um, and that's another way of doing preference training that's a little bit more flexible. And also, I believe that with KTO, you might not even need the SFT step. It's been shown that you could go directly from, if you have this data set, directly go to KTO training, which is really interesting.
Nice. Yeah, sounds cool. I haven't read about it. Sounds interesting. KTO. KTO, is it instead of
Yeah,
KTP?
just KTO, yeah.
Okay, great. Okay, I'll look at it. Nice. Any questions for Michael about the PO in general? No. Cool. Then, okay, someone asked. The notebook was 3. Yeah. Someone's asking the epoch, like the wood example was epoch 3. And like someone's asking what happens at epoch 4 and 5. Do you have it there? Yeah. Basically, someone's curious if basically when it gets into this loop of repeating wood, does it never gets out? So that's epoch 3. Then if you scroll down, yeah, epoch 4 is the same. Right. Yeah. Michael, you're muted. I don't know if you were talking.
Yeah, I was yeah, so it's kind of stuck repeating itself. And I think that's where the term collapse comes in, where I don't think it will kind of recover from this state.
Yeah. Same as when our network is stuck on a local minima, and
Mhm.
then you cannot go away, or it's very difficult. All right. Then Eddie, are you here? Yes.
Yeah, I'm here.
Hi, Eddie.
Let me share my screen. Please let me know if you can see my screen.
Yes, we can.
Okay, so I have 3 pieces of data I want to share with you. First is a high-level presentation of the RAG fundamentals. Then I will walk you through, let's say, a dynamic diagram, and then some examples in Colab. So what is RAG? So it's it's a method to be used for different large language models to fetch relevant data from reliable sources, external sources. So we all know that a large language model cannot answer to something he was not trained on. So which means that if we have some private organizational data or personal stuff, which we don't want to use for a fine-tuning process, we can store this data in private or public, for that matter, database, and we can implement this method, which is called retrieval augmented generation. And we all know the hallucination effect of poorly trained large language models. And what we want to make sure that the answer is grounded in reliable data. We have control over it. So at a high level, how the stuff works is we need first to save our data, which, as I said, it can be private, can be confidential, etc. And within this storing process, we need first to split these documents into small pieces and to embed into vector representations. I am not going to say about the vector representations and embedding because everybody knows. And then all these vector representations of the chunks will be saved in a vector database. And the market is super rich with solutions, public cloud-based, local like Face or Chrome or Pinnacle, a lot of solutions. Every vendor has a solution. Then the next step is to retrieve the context. Basically, the idea is that when we want to ask a question, we want to ask a question, a large language model, we want to enhance the context, or we want to enhance this question with a broader context. So the user query is also embedded using, of course, the same algorithm and the same dimension. And the overall system will perform a different searching methodology. For example, it can be nearest neighbor search algorithm to find the chunks which match the query. And then all these chunks which are relevant to the query, together with the query, go to a large language model, which can be private, can be OpenAI. And then based on this enriched context grounded in relevant data and trusted data, the large language model will produce an answer. So there are multiple, I did some research in the last days, there are multiple techniques, advanced techniques for retrieval augmented generation. Because there are some limitations to the standard and traditional RAG method, and different variants of RAG basically imply different, let's say, approaches. For example, different type of searches. For example, a hybrid search between a dense and sparse, multi-step retrieval, contextual re-ranking. So basically, all the chunks relevant to the query are re-ranked and organized from the importance point of view. Another improvement is this hierarchical organization of information, which basically this principle is implemented in Raptor. Is this one here? Is one of I played with Raptor and I didn't test all of them. Each technique, I tested only some of them. So far, I'm very happy with Raptor, which basically takes an hierarchical approach to the idea of extracting relevant chunks from a bunch of different documents. So this is the high-level, let's say, theoretical presentation of what is. And one more thing, not to forget about that, is that we often have this question: which one is better, either RAG or fine-tuning? And the standard answer is depends. Yeah, so it depends on the use case you want to solve. For some cases, RAG might be a better solution than fine-tuning. For other situations, fine-tuning might be better than RAG. From my own experience in the last, I don't know, 2 years, I noticed the best solution is a combination between fine-tuning and RAG, and that at least gave me the best and most accurate results with combination between RAG and fine-tuning. I did fine-tuning with Llama 3.8b, and I use RAG with my personal PDFs, and the result was super good. So this is the overall high-level presentation. Second part of my is consisting of I did stuff yesterday, and I think it's very cool. Actually, yesterday I learned how to do it. So I did this this dynamic diagram in Draw.io, so which shows the overall flow. Can you see my the flow?
Yes.
Okay. So basically here we have, let's make it bigger. Oh. If somebody is interested how I did it, I can explain. It's very cool. So we have a private database. Every type of data you can imagine: audio, video, images, text, and all the possible known formats. And then we turn this data into the step one. We turn this data into chunks, which will have a different size. The size of the chunks is it's a very interesting topic. It's a very interesting topic. And requires a lot of testing. Then the second step is that all these chunks are embedded. So in other words, are turned into vector representation of the of their semantic meaning, basically, and are stored in the vector database. Are turned into vectors and are stored into a vector database. Is to be okay. Which of course performs with indexing of its vectors. Then the user comes with a query. He is asking something. His question goes through the embedding model, the same embedding model, which also is turned into a vector. And then we perform at seven. We perform a search. For example, there are multiple methods, but one of them is AN search. So we have here with blue all the possible, all the existing chunks within this embedding space, and the user query, which is depicted with red, and with green I depicted the retrieved vectors which are closest to the query. And all this bunch of all the content within this red circle, which contains the green green points which represent the retrieved vectors relevant to the user query with red, are sent to become basically the new prompt. Yeah, and this new prompt goes to a large language model. Any possible. I tested this architecture with all possible combination: public, cloud, private, open source, and closed source like OpenAI. And then the user happily receives the answer. And of course, we can also say that we can ask the model to give the references within these docs we have in our knowledge base, to have a very, very grounded answer, grounded within reality, within our own knowledge base. And in this way, we solve the hallucination problem. And this is the second part. And the third part is a small demo. So I use my OpenAI key here. I save it here in keys. So I forgot to mention that there are at least two main frameworks where this RAG solution can be implemented: LangChain and LlamaIndex. I played with both. I prefer LangChain due to historical reasons. I'm more familiar with LangChain. But LlamaIndex is also very powerful, very powerful framework. So I installed this library, OpenAI. FAIS is the database. long chain with framework, tick token, everybody knows, and then from this we import the necessary modules which are relevant for creating this chain. We will see later on what does it mean. Then here I have a bunch of documents. So this is the first example of the first use case where I have some documents, and then I perform the embedding using my OpenAI key. Then I save the vectors into the FAIS database, and I create an object to be a retriever to be used for retrieving the relevant chunks from the database. Which is cosine similarity, which basically means that the search type is cosine similarity. Basically here means that between the vector which represents the query, we verify or we measure the cosine with all the other vectors which represent our content, and we will pick up the K2, the two closest vectors / chunks closest from the closest to the query. So that means which have the lowest value for the cosine function between the query and these two vectors which are closest to the query. So here we can notice a big limitation actually for RAG system, which is in this case 2. So because how do we know if the relevant chunks, how do you know if we don't have more relevant chunks to my query? I might have 10 relevant chunks to the query. So if I put here 2 or 5 or whatever, it doesn't matter what is the number, I introduce this limitation. Yeah, the database can contain more data than this value K I hard code here. So I instantiate an OpenAI object, and here I define the chain. Basically, I use this retrieval QA from chain type method. Here this option stuff basically here, that means that so my question is turned into a vector, and I verify in my database all the relevant chunks for my query, and I just put all this when I provide the answer or the context, the overall context / prompt, I will create what is the word? I will put in series somehow all the chunks. There are another option which is called map and reduce, and we can test it if you want. Yeah, there are other methods, for example, map and reduce, and in this method we can basically for every single match. So we get the first chunk from the database, and that goes to the large language model, and we get an intermediary response. So map and reduce option will perform this interrogation of the large language model for every chunk, and then it will make a summary from the responses and will give us a final answer. As you can imagine, it implies multiple API calls to the large language model. If we use, in this case, OpenAI, it will be more expensive but more accurate. So here the question, which is what is a RAG, and I run method here, and I get the answer. Yeah, and this answer is from my documents. These are my documents. Yeah. Okay, so this was the first use case. The second use case, let's say, okay, let's use Wikipedia as a source for our data. Yeah, so I install this API. We need to also to import some loaders for Wikipedia. There are a lot of loaders for all possible data source. I use Wikipedia. It was easy to, and this is the page. And then I make a search to give me, I search Wikipedia to find this page retrieval, and I select the first answer, which is this page, retrieval augmented generation, which is the page. Because I will use this page as my source data. I create an object, a loader for this page, and I load it, and I loaded these documents from this page from Wikipedia. I'm splitting I want in this use case to use recursive character splitter to split the text into chunks. So I create this splitter object which will make a chunk from these documents from Wikipedia. And as I said, the chunk size is not, it's a very tricky. It's a very tricky design option here. What should be the chunk size? Because if it's too big, or if it's too small, I might lose the context. If it's too big, it might create some confusion. So the right size, according to my experience, is means that whoever does this chunking, he must have a good understanding of the document, how the data is distributed across the document. For example, if we have, let's say, an essay, and this essay, let's say, has multiple ideas which are distributed across multiple paragraphs, we need somehow to fine-tune this chunk size to a value which is capturing basically one paragraph which stores one idea, yeah, in order for this operation to be successful and meaningful. So this one is tricky. I selected here randomly 500. So it's not, and overlap is necessary to make sure that if the chunk ends in the middle of the sentence, I want to overlap the chunks in order to be sure that I'm covering all the meaning which is presented within a document. So in this case, I have 25 chunks, and need to store these chunks into files. And I create a new retriever object, also similarity search, and I want to use K2 just to compare the results from the previous example. And I instate another OpenAI instance here. I put temperature 0. It's obvious. I create a new chain using the same method, retrieval QA from chain type. The same option here stuff. As I said, this is also an important fine-tuning parameter, if I can say so, fine-tuning. And then the same question: what is the main topic, or what is RAG? What was the question here? Yeah, what is RAG? Let's use the same. Yeah, so this answer is coming from Wikipedia. It's a good answer. It's no doubt very, yeah. And the third and last use case is I want to use a local PDF as a data source, and I use as a PDF the same with Wikipedia. Yeah, so I copy pasted the Wikipedia content. Let me show you real quick, just to have the same reference. So this is Wikipedia. Yeah, this is the site here. Yeah, I put it here. So I wanted to compare between apples and apples, the same methodology, the same data, but different approaches. Wikipedia / local PDF. So this is the local PDF. Yeah, so this is local PDF here on my collab. Okay, of course, in case of let me execute it because I can do it again. So this library to read the PDF files, then upload from my computer. File is loaded. I load it. I create a document object. I split this document. Again, I use the same 500 and over the same overlap values. I create another phase instance for as a vector store database. I create a retrieval using the same search type, which is cosine similarity, and the same number of matches, the same type of, the same number of relevant chunks. Is a better way. An instance of OpenAI. I build the chain using the same method, the retrieval key from chain. Same option here, stuff. As I said, there are multiple options, different performances. And let's ask the same question, which is, it's a simple question, obviously, but just for this purpose of presentation. So now the answer comes from the PDF file. So it allows these models to respond to user queries by referencing a specified set of documents in addition to using our own training. This was the answer from my local PDF, and from Wikipedia, the same. Yeah, same. Allows models to respond to user queries by referencing a specified set of documents. Let me copy it, put it one below another. So this was from Wiki. This one, PDF local. So let's see what is the difference. Yeah, the answers are identical, which is what I want. I mean, I want predictability. Given the same parameters which I designed for this chain, I expect the same answer, to receive the same answer if I use local, or let's say I am accessing external or something like Wikipedia.
Really
Eddie,
cool.
really cool. Can you remind us once again, how did you ensure that the generated content from the two different modes, PDF and web, were the same answer, roughly?
So first, condition data should be the same. So in case of Wikipedia example, which was use case number 2, I used this page, which is a retrieval augmented generation, which is this page. So data should be the same in order to have a meaningful measurement comparison. So this was data case 1. And data in case 2, I just copy paste this stuff and I save it as PDF. And I have this file, which is the same file, but it's a PDF file. So this PDF file in the second use case was loaded locally from my computer. So the original data is identical. And the second part of the answer is that I use the same libraries, the same approach to split, the same size of the chunks, the same overlaps. So basically, I use the same logic to generate the chunks, and of course the same question, the same query. So and the same query and the same number of. Let's change it. Let's make it here 5 to get more context from my local PDF. See if I have the same answer or not. And
yeah, that was exactly what I was getting at. Thank you for doing this.
Yeah, so this is the new answer. Let's put it. So this is the answer from. I think I messed it up a little bit. Use case 2, right? Yeah, this is the answer from. Yeah, so this is the answer from Wikipedia. And I changed the number of relevant chunks which should generate or should be added to the original query to create a new context. Yeah. So this is with K5. So if we, so this is wiki with K5. So K5 means I pick up from Wikipedia 5 relevant chunks to my question, and yeah, so so with 5 the answer is richer, is more precise and more detailed. It describes what it means, RAG indexing, storing, which are the stages. It's a different answer basically. I mean, it's much better with k equal to 5. Which makes sense because now the OpenAI received my question, what is RAG, plus 5 chunks from Wikipedia. Still, they said the disadvantage of this RAG approach is that it might be it is very likely that that Wikipedia has when we chunk the ultimate Wikipedia content to have more than 5 relevant chunks regarding to this question, what is RAG? But because it's a fixed number of chunks which will be used to create to enrich the context, the original context of the query, will be finite, and that means that we might miss pieces of information, important information, which go beyond this value K5. So that's why for addressing this challenge, more advanced techniques should be employed, yeah, like Raptor. These techniques, if you want, I can make a presentation with, as I said, I prefer Raptor because I resonate with their philosophical approach for doing this improvement. So, yeah, so if somebody wants to, or there is interest for these advanced techniques, I can prepare something similar. But this is for, as I say, traditional, what is RAG, let's say. If there are any questions on. And also this picture, which I like. By the way, yesterday I learned to do this animated stuff. Very cool.
And
very easy. And very easy.
I always wonder how people
look
those diagrams.
Yeah. So let's make a link between the knowledge database and the query. So we go here, select and we go to the query. And here, no, I need to see. I need to have properties. Where is properties? They said it's new knowledge for me. Here. So here we select the type of line, and voila. So it's this click here, flow animation, and you have this, this stuff which is flowing now.
Very cool.
Super simple. I mean,
yeah, very nice. I had one question regarding the chunk sizes. I guess, like, correct me if I'm wrong. I guess if we have like chunk size that is relatively big, like the one that you use, 500, the chunk is rich in information, right? If we have a chunk size that is very small, then there's very few information in that chunk. Do you know like any trade-off between using
No,
small versus
no.
bigger chunks?
From my experience, as I mentioned, from my experience, you need to understand the text. I mean, you need to think like RAG, basically. I mean, you need to know the text. So let's say we have one page, yeah, and within one page we have let's say 2 ideas, yeah. We have 2 ideas in this page, which means that you need to know the domain in the first place. But let's say we have 2 ideas in one page, A4 page. We have 2 ideas, and each idea is presented in, I don't know, half of the page, yeah, which means 4 paragraphs. And second idea in the next 4 paragraphs. Well, if you want to have a smart RAG system, you need to capture these 4 paragraphs in one vector. Yeah.
Yeah.
And you need to. I mean, for me, it is a trial and error. I don't have a simple answer. It's first you need to understand the distribution of important data in your document, and then we need to really play it with it and to capture somehow this distribution of ideas within your chunks in a way in which you have some, let's say, you have a good representation of your idea within the vectors. So as I said, RAG is something which should be addressed, let's say, on a case-by-case basis, and depends on the use case. It depends on the specific use case somebody need to address. So as I said, if you have a private data or corporate data, or what is the word? You have I don't know, processes, internal processes for your company. Probably for sure, RAG is the best solution. For other things, large language fine tuning, I think it's suitable. So when you want precision and determinism, RAG should be used.
Yeah.
Yeah. Because determinism is important. I mean, we have this, these large language models have this nature of not being deterministic, and but if you need in your use case this precision, accuracy, and I think RAG must be a component of the whole architecture.
I want to make a question about also what you were talking about, the structure of the document. I'm working on a use case where the documents that I'm trying to use for the RAG, there is a lot of them, and they have a date and also a specific title at the beginning of the document. So one of the issues that I'm finding is that if I chunk the document, then the parts that are not the first chunk are going to lose some part of the information. So my question is, in that case, should I relate them in the vector database with the first chunk of the page, or maybe just copy the first part of the document in the other chunks?
So I would say that for this kind of, so basically you need to, your question basically is what should we do with metadata? Because this would be the name of the chapter, or and there are these advanced methods which I mentioned, which also take into account the metadata. So all the information related to a specific part of the document. So what I showed is just this simple RAG. Yeah, it's not very powerful. It's there are a lot of cons for this approach. For example, fusion retrieval, this basically combines, for example, standard keyword search with vector cosine search. As I said, I didn't test all of them, but you need to somehow to use to research one of them and to capture also this metadata. This is what you want. You want your metadata to be captured and linked to the chunks which belong to this metadata. But for that, you need more advanced. I will need to think about that if you want. I want to think, and I can next time to tell you, to ping you which approach I would take. Another one which I tested is graph RAG, super powerful. Basically, the idea here is that everything everything is, all the context is turned into nodes and edges. So basically, it's using the graph theory, and the entire document is mapped into these nodes and edges. And when you ask a query, then the answer will, the retrieval will find something relevant to your question, and then this approach will follow a path tree basically, and will pick up all the relevant data for that query. It's a very powerful RAG method using graphs. Corrective RAG is self-evident. Yeah. So there
Eddie,
are.
I had a
Yeah.
question. Do you have any ways of doing or like automated evaluation metrics that you can apply to a RAG system like this? So let's say you want to kind of treat your chunk size and some of these other things, parameters that you can kind of change as hyperparameters, and you want to run experiments and see how, if that influences your system. Are there ways to score like the outputs automatically, or is it just like looking at the outputs manually and eyeballing them and then assessing the quality?
That's a good question. I would rely for clear reference for the answer. So whatever the answer will be, if I receive a clear reference within the document, for me is good enough, because if I ask something and I receive, let's say, a combined answer, and every sentence from this answer has a reference to the document, I go to the document manually, and I see that this is not any hallucination or something. So every piece of the answer has a one-to-one mapping to a space in that documentation exactly as it is. So the sense is not changed, or the meaning, or no fancy wording or something. So this would be, for me, my metric is to make sure that the answers are grounded in that original text, and it's not any creative activity from the large language model. Now, automated methods, might be it's a topic for a new research paper, Michael. So you publish it, and
That's hard.
I don't know, but I really don't know. I mean, okay, let me think. So if you automate, if basically you add to the pipeline, you add an additional layer of verification, and somehow you pick up the components of the answer and verify, let's say, sentence by sentence, that this stuff is searchable, or these things exist in your original and trust database. Yes, you can do that. Yeah. So I think that. So you add an additional layer of automation and metric validation, or whatever you want to call it, and you can automate. You take any piece of the answer, and you perform a Control F function within your database and see if this stuff exists or not. And if it does exist, then the answer is accurate, is grounded in your database. If not, is hallucination from the large language model, or something which LLM make it up. Yeah, and you can say, okay, if it's not okay, then do it again, or I don't know, change value K, for example. Yeah, I mean, you can develop. I think it can be developed, but you need to have you need to define what exactly is your requirement. Yeah,
Yeah.
When you say metric, metric for exactly what? For me, metric would be to be sure that the data I'm receiving is grounded in reality in my database. This is the point. And I need to double check that to see if every piece of information, I can find every piece of information in my database, which I trust. And if if I want to automate to achieve this objective, which I just said, I decompose the answer. I make a kind of reverse engineering. I decompose the answer in smaller sentences, and I verify if each sentence exists in my trust database. And if yes, it's okay. If no, then do it again, or I don't know, something, reduce the value k or something else. But yes, if you have a clear objective, like I want data to be 100% sure from my source, yeah, I think we can add another layer to this pipeline to automatically verify.
It's kind of maybe domain specific, and you might have like these heuristics that you create for your specific application that you're looking at. Yeah.
So what I did it for IT. So I'm an IT guy. So what I try and what I want to do, basically, I want to create a new discipline. I want to create a discipline from which is IT, networking in my case, and AI, and to have a new approach for my discipline, which was my dream, basically. And which means that when I work with these tools, I use data which I know and I understand very, very well. I don't use random data like medical reports, which I'm not able to understand, or other stuff. I'm using only data which I know. Yeah.
Good news also related to Michael's question is that on the next book, engineering, I was checking, and there are 2 full chapters about evaluation methodology and evaluation of RAG systems, AS system in general, agentic systems, stuff. So, there's one question in the chat regarding this slide, actually, the item number 11, context compression. The question is if you have any reference about it.
No. What I can show is I didn't test it. As I said, I tested only a part, some of them. I just wanted to show you in this present. I did this research these days to show that it's a big research space for this RAG stuff, and there are a lot of solutions and advanced solutions, I should say. And what I want to say is that if somebody understands very well his own use case, which are the requirements, then it is, let's say, relatively easy to map this particular set of requirements with the specific functions which are delivered or provided by each of these advanced RAG techniques, and in order to find the best fit for a particular use case. So what I want to show you, let's see if I can find it real quick. Yeah, so is this guy from I don't know him. Here he has this data, he has this GitHub account, and he presents here all his for example Raptor, which I said that I tested. Recursive abstractive processing and thematic organization for retrieval. Yeah, so I like it because it's using a hierarchical structure of all the summaries, and basically the idea is that when you have a bunch of documents, which basically this Raptor addresses the scale problem. When you have a lot of documents, this advanced RAG can create a hierarchy structure and of the summaries. Yeah. So when a query comes, the query is matched against summaries, and then only, so it's a two-step process. So first it matches the summaries, and then based on the summaries, this Raptor goes to specific documents which created the summary. So the search area is more precise if we have, let's say, a big amount of documents. So I tested it. If you want, I can make, I show you the code and to develop a presentation, I don't know, next week or whenever. Re-ranking, another one, which ranks the, which I also tested, which ranks the chunks. Simple RAG, it was this one which I showed you with PDF processing and different retrievers. Yeah, yeah, but I mean, if you walk through, let me put it in the chat. If you walk through this big database with information here from this guy, which I don't know him, and read the description of each type of advanced RAG technique. Yeah, this is also very cool. Microsoft Graph RAG, as I said, using graphs, very powerful, very scalable. Yeah, so if you work through all this, yeah, you can find something which best fits your use case.
Nice, thank you. Yeah, that if you are available to continue talking about RAG, maybe Raptor next week, that would be great. With that, we'll be like kind of transitioning to like from just pure LLM stuff to more LLM systems, and that's because next week it is, what day is next week?
Yeah.
It's 9. Sunday is 9. Then we will meet on 11 with Sebastian, and then on 16 it would be like the kickoff of AI engineering. Yep. So yeah, if you.
So Carlos, I'm sorry I don't have an answer for you, but I will search for your question and I will tell you next Sunday.
Okay, thank you. But anyway, I think more or less you gave me the clues, but thank you anyway. Good presentation, by the way.
No, thank you.
Yeah.
Thank you.
Yeah, thank you both. Thank you, Michael. Thank you, Eddie. Great job as always, as usual.
Yeah, thanks, guys.
All right. Anybody has any questions before we log out? Cool. Okay, cool. I'll upload the video of this meeting during the day, and yeah, see you next week. Thank you.
You guys. Ciao, ciao.
Bye.
Thank you. Good week.
Thanks, everyone. Great
Thank you.
presentation today.
Thank you much.
With Michael and Eddie. Yeah, bye.
Yeah, ciao, ciao.